Hello everyone. So in this quick video, I'm going to describe one of the more challenging your turn problems in the second lesson. So this has to do with the third your turn slide and using the empirical rule to find probabilities. So the question says that IQ scores are bell-shaped with a mean of 100 and a standard deviation of 16. And if you hear other people talking or loud sounds, they're doing construction outside my house, and so that's what it is. Please forgive me. So IQ scores are bell-shaped with a mean of 100, standard deviation of 16. And so the first question asked you what's between, or what's the probability between 84 and 116, and that comes straight from the empirical rule. But first I want to show you how to visualize this problem, or how I would visualize it. Hopefully this will help. So in bell-shaped, you'll see me draw this a lot, although hopefully better, something like this, okay? So my data sort of looks like a bell-shaped curve. In the middle, at the hump, is going to be the mean of 100, and then when I spread out, if I go up one standard deviation, so a little bit to the right is 116, down here is 84, I can go up to, or more, 2 standard deviations there. Okay, so I just put some tick marks. This is, you can think of as an x-axis line. Okay, and so I'm asking what's the probability between 84 and 116. The empirical rule, I give you a few options, especially in the graded homework. I ask you some questions before you do this. But here, before you use the empirical rule, you have to ask the question, is the data bell-shaped? Okay? And bell-shaped means it's symmetrical around this middle line. Or maybe I should put... It's symmetric around that line, and it looks like a bell. And so it is, and so I can use the empirical rule to say something about the percent, or the percent of observations which are between 2 points, which in turn, for our purposes, is kind of the same thing as probability. Okay? So the empirical rule says that 68% of the distribution lies between plus and minus 1 standard deviation of the mean. Okay, and so it turns out that 84 is the mean minus 1 standard deviation, and 116 is the mean plus 1 standard deviation. So the empirical rule says that the area in between these two, or the number of observations, rather the percent of observations between these 2 points here, is 68%. And so that's the answer to this question, 68%, or 0.68. Okay? Now, the second question, which is the much more challenging question, is what's the probability that I see a random person with an IQ greater than 132. Okay? So we're going to use the empirical rule, but not directly. We have to do some other stuff. Okay? And so again, I'll draw the same picture as we had above. Okay? So my drawing is terrible, but it should be a similar picture as above. I'll just give up after this time. Okay, so make believe that picture above is the same thing. We have 100, 84, 68, 116, and then 132. I want the probability of seeing an observation greater than 132. And so the question I'm asking is, what proportion of observations of everyone ever who had an IQ score, sort of the population, what percent is greater than 132? Okay, it's greater than 132, so that represents this area or this bit right there. Okay, the empirical rule doesn't tell us that exactly, but what it does tell us is what lies in between this point and this point. Okay, the empirical rule says that in here are 95% of the observations. Okay, so in here lies 95% of the observations, and so I've got to think about if 95% are between these 2 points, then how much percent is out here from this point on and down here from that point on. Okay? So if 95% is in between, that means that the rest, okay, so lower than 68 and higher than 132, is 5%. If 95% is in between, then 5% is outside of that range, because if you have all of the observations, then that's 100% or 1, okay, if we think of proportions. So but it's 100%, so that means that 5% is outside of the range, 95% is in between 68 and 132. Okay, so then I'm almost there. The last thing that you need to account for is I don't know how much is, I want to know but don't know how much is here and then how much is down here. Because the distribution is symmetric around this middle point, because it's symmetric, the same amount of data is on the left side as is on the right side. Okay? Because it's symmetric, because I can flip one side of this picture over, and if I put it on the other side, it should look exactly the same. Okay? Because that's true, I know that half of this 5% should go over here. So 2.5%. 5 divided by 2 is 2.5. And then over here is also 2.5%. So that means, so there is my answer. That means that the probability that I see a random person with an IQ greater than 132 is 2.5%. Or, as a proportion, 0.025. Okay, I know that still might be a little confusing, but hopefully that helped